Hello, my name is Carlotta Vaughn, and I'm here today to share my research proposal, Raising the Bar in After-School STEM Programs at the Elementary Level. In today's presentation of the research proposal, we will go over the research questions, the need for the study, the methodology, and the proposed data analysis. There seems to be little debate over the significance the role STEM education has in improving student achievement. Multiple studies show that students who participate in STEM perform higher academically. One may contribute the success and rise over the years of STEM education to President Obama's Educate to Innovate initiative in 2009. Even with a decade of research demonstrating STEM education's ability to increase student academic achievement and interest to pursue STEM fields in college, little research has been conducted at the elementary level in STEM after-school programs. It is well known that after-school STEM programs provide learning experiences that most traditional educational settings lack the means to emulate. This is due to the fact that after-school STEM programs allow students to delve deeper into the curriculum without the time or testing constraints found in the traditional classroom. However, even with the knowledge of the positive attributes of after-school STEM programs, there is little research into their effects at the younger grade levels. In the conclusion of Young, Ortis, and Young's meta-analysis of 84 research articles, they call for a further research into the effects of after-school STEM programs at the earlier grade levels. This research study aims to meet theirs and other researchers' call for further investigations into after-school STEM programs at the elementary level. There are two main research questions proposed in this research study to investigate the influence of after-school STEM programs on student interest in STEM and on their self-efficacy at the elementary level. The first question is, what factors of an after-school STEM program influence student interest in STEM at the elementary level? This question is based off the call to action from Young, Ortiz, and Young mentioned earlier. This research question will strive to fill a gap in the literature of after-school STEM programs. The second question is, what effect does participation in an after-school STEM program have on student self-efficacy at the elementary level? This question is based on my own research interest of student self-efficacy. It is also relevant to the education sector because of self-efficacy's correlation to the overall. A quantitative research method will be utilized to answer the research questions. This research study will investigate the influence of after-school STEM programs on student interest and self-efficacy at the elementary level, utilizing two separate Likert scale surveys. The primary focus for this research study will be on 5th and 6th grade elementary students during the 2020-2021 school year. Data will be collected at the beginning and closure of the after-school program, which is roughly 24 weeks long. This study is part of the post-positivist worldview, as it is measuring the attitudes of the students before and after their participation in the after-school STEM program. The participants will be surveyed during the initial and final sessions of the after-school program. During this time, they will complete 2 Likert scale surveys in each of these sessions to collect pre- and post-numerical data on the dependent variables. The instrument that will be utilized to analyze self-efficacy will be a Likert scale modified from Bandura's Children's Self-Efficacy Scale. Students will self-report using a 5-point Likert scale in the areas of self-regulated learning, enlisting social resources, meet others' expectations, and enlisting parental and community support. The instrument that will be utilized to determine factors that influence student interest in STEM will be a Likert scale developed by the researcher. The 5-point Likert scale survey will ask students to rate how they feel from not at all important to extremely important about different elements embedded into the after-school STEM program. These elements will include items such as hands-on activities, student interest activities, collaborative activities, and teacher-led activities. The data collected in this proposed research study will be analyzed and compared utilizing IBM SPSS Statistics 26 for Windows and Mac for those participants who have both data points collected. Since the nature of the research questions are based on the group comparison of student attitudes before and after participation in the after-school STEM program, the statistical test that best meets the needs of this proposed research study and will be utilized is a one-sample t-test. According to Levin and Fox, the t-ratio is a parametric test utilized for comparing a same sample that is measured twice, such as the pre-test and post-test being utilized in this study. They also note that this type of statistical test is used when a participant is comparing themselves to another point in time. This type of statistical design is called a panel design. Using the data points collected from participants who are not able to complete the initial and final surveys will not be included in the final results. However, to ensure there is no response bias, a respondent/non-respondent analysis will be implemented to ensure the non-responses do not differ substantially from the collected participant surveys. An analysis including mean, standard deviation, and range scores will be provided in the final report along with the t-test results. The data will be provided in 2 separate tables dependent upon the research question, showing the differences between both data sets. I want to thank you so much for taking the time to listen to the presentation for the research proposal on raising the bar in after-school STEM programs at the elementary level. Have a great day.